Picture this. You've got a viral video on YouTube, but your analytics show surging interest in Latin America. You need that content localized fast. Enter the AI Video Localization Studio. Here's how it works. You drop the video link into the system. Behind the scenes, yt-dlp springs into action, pulling down the source file from YouTube or any of the 1,000+ supported platforms. No matter if it's TikTok, Instagram, or some niche hosting service, yt-dlp handles it seamlessly, ensuring you own the media before any transformation begins. Once the video is ingested, Whisper takes over. OpenAI's open-source transcription engine churns through the audio, converting speech to text with support for 99 languages. This isn't just raw captions, it's the foundation for everything next. The transcribed text feeds into translation pipelines, but before that, OmniVoice-Studio gets to work. This tool clones the original speaker's voice from a 3-second clip or generates an entirely new voice from scratch, adjusting pitch, age, or accent to match your target audience. When the Spanish dubs roll out, they're not robotic recitations, they're natural, expressive performances built offline, without shipping data to any cloud. Now you've got translated text and localized voice. Remotion steps in to rebuild the video. This isn't just slapping subtitles on a frame, it's dynamic rendering. Imagine lower thirds animating in Spanish text, voiceover syncing perfectly with on-screen action, or even scene transitions adjusted for cultural nuance. Remotion treats video as code, using React principles to generate frames with precision. The output: a fully revoiced, captioned MP4 ready for prime time. But localization isn't done until it's published. Postiz-app handles the scheduling, letting you map content to specific regions across platforms. That Spanish version. Set it to drop at peak hours in Mexico City and Madrid simultaneously. The tool even lets you A/B test thumbnails or tweak posting schedules based on engagement predictions. Finally, Coolify ensures the entire pipeline runs smoothly on your infrastructure. This self-hosted deployment engine manages containers, databases, and scaling, no vendor lock-in. Whether you're running on a Raspberry Pi or a bare metal server, Coolify keeps costs predictable as your localization needs grow. This is the end-to-end stack: ingestion, transcription, voice synthesis, video generation, scheduling, and deployment, all open source, all under your control. Let's break down how each piece fits into the architecture. Here's how the data flow unfolds in a cohesive architecture, tracing a single video from ingestion to global deployment. A video publisher starts by submitting a source URL, say, a YouTube link, to the system via an API endpoint. Yt-dlp initiates the process by downloading the raw media. It outputs a standardized MP4 file stored temporarily in a shared object store, emitting an ingestion complete event. This event triggers Whisper, which pulls the MP4, extracts the audio track, and transcribes it. Whisper's API contract requires a file path and returns a JSON structure with timestamps and text chunks. The transcript is saved to the same object store, firing a transcription-ready event. OmniVoice-Studio listens for this event. It consumes the transcript and original audio, using its voice cloning engine to generate a dubbed track in the target language, let's say Spanish. The API here requires the audio file path, transcript JSON, and language code. OmniVoice outputs two files, a translated transcript and a WAV dub, stored alongside the original assets. A dubbing complete event follows. Remotion reacts to this event. It pulls the original MP4, the dubbed audio, and the translated transcript. Using its programmatic video API, Remotion replaces the original audio track with the dubbed one, burns in captions from the transcript, and renders a new MP4. The service contract here involves passing video asset URLs and receiving a rendering status webhook. Once done, it uploads the final video to storage and emits rendering complete. Postiz-app catches this event. It ingests the rendered MP4 along with scheduling metadata, target platforms, release time, etc., provided earlier by the publisher. Postiz API queues the video for distribution, creating social media-specific variants if needed. A scheduled for publish event confirms the plan. Finally, Coolify handles deployment. It provisions serverless resources for the video's landing page or API endpoints if required, using its deployment API to ensure the asset is hosted securely. Coolify's event deployment ready closes the loop, notifying the publisher. Each service boundary is strict. yt-dlp handles media acquisition, Whisper processes audio, OmniVoice localizes content, Remotion recomposes visuals, postiz manages timelines, and Coolify orchestrates infrastructure. Storage entities raw videos, transcripts, audio files are decoupled, allowing parallel processing. The data flow remains linear but stateful, with events governing handoffs, ensuring scalability and fault tolerance. This pipeline transforms a single video into a globally accessible asset without manual intervention, each tool passing its output to the next via well-defined contracts. Start by standing up yt-dlp locally to validate media ingestion. Use Docker Compose to spin up a container that pulls a test video from YouTube using its CLI flags something like yt-dlp, best video plus best audio. Verify the output files land in your specified directory with correct formats. Once ingestion works, integrate Whisper by piping the downloaded audio through its API. Test with a short clip first, transcribe, check the timestamp alignment, and ensure multi-language support works by switching the language parameter. Next, connect OmniVoice-Studio for voice cloning. Feed it a 3-second voice sample from your test video and verify the cloned voice matches the original tone. Use Remotion to create a basic video template that accepts dynamic parameters like changing background colors or text overlays via JSON inputs. Test rendering a 10-second clip to ensure performance is acceptable on your local machine. For local development, use Docker Compose to orchestrate all services. Define a network where yt-dlp exposes an API endpoint. Whisper runs as a gRPC service, OmniVoice uses a REST interface, and Remotion handles rendering via webhook triggers. Environment variables should control paths for downloaded media, model locations, and render outputs. Set up a N file with defaults for development. Background jobs need a queue system. Use Redis as a broker with Celery workers handling tasks like downloading, transcribing, dubbing, and rendering. Prioritize jobs based on urgency. Say, videos due within 24 hours get higher priority. Implement retries with exponential backoff for flaky operations like API calls to external services. Monitor job status through a simple dashboard or logs. When moving to production, deploy with Coolify. Set up a server group in their UI, configure deployment pipelines for each component, and use their built-in monitoring for resource usage. Ensure databases for metadata, like video IDs, timestamps, language codes, are backed up daily. Use Kubernetes for scaling worker nodes during peak loads. Test the entire pipeline with a sample video. Ingest, transcribe, dub into 2 languages, render, and schedule via postiz. Check that all file permissions are correct and secrets like API keys are encrypted. Finally, validate the end-to-end workflow. Monitor logs for errors, measure how long each step takes, and optimize bottlenecks like splitting large videos into chunks for parallel processing. Use automated tests that run on each commit to verify integrations haven't broken. For example, a test could download a video, transcribe it, generate a dub, and render a video, then compare file sizes against expected ranges. If any step fails, the pipeline should alert developers via Slack or email. To tie the entire localization workflow together, you'll need to configure each tool with specific commands and environment setups. Start by pulling videos using yt-dlp with a command like yt-dlp best video xmp4 best audio xmp4, ensuring you specify formats compatible with downstream tools. For transcription, run pip install OpenA Whisper and execute Whisper input mp4. Model base, language auto to generate timestamps and text, leveraging its multilingual support without cloud costs. Next, dubbing requires OmniVoice-Studio. Install Python 3.11 fmpeg and run OvoStudio to launch the interface. Use the CLI for batch processing with OvoClone, voice path, my voice WAV, text script, output file output WAV, though the readme notes GPU acceleration is recommended for faster processing. For video reassembly, Remotion needs Node, Gs16+, and a config like Remotion init my project, then edit sarsi-root.tx to overlay captions and resync audio. Note Remotion's license requires a paid agreement for commercial team use beyond small projects. Deployment via Coolify starts with their install script, curl ssh, then ssh into your server to configure app environments. Set Coolify env production and deploy with Coolify deploy. App my localization stack. Be aware the free self-hosted version lacks auto-scaling, while the cloud tier starts at 5 MB. Finally, schedule localized videos with postiz via Docker Compose upd for self-hosting, then use their API to queue posts with curl x posth authorization, bearer token, dgrl, file mp4, schedule, 2024 and 1101 den. One practical build step you can take today is to test yt-dlp's caption extraction by running yt-dlp, write sub, skip download, which downloads both video and subtitles, ensuring compatibility with Whisper's input requirements. If you're wondering how to handle right-to-left languages in Remotion or optimize OmniVoice's GPU usage, leave a comment below. Those are common pain points we can troubleshoot together.